My name is Venkat Dinesh Raj Kanuri, and this video is being made for my MSc dissertation for MSc IT in Leeds Beckett University. The topic I've chosen for my dissertation is developing a prototype of an agent initiated network management protocol based on the CNMM hypothesis to overcome SNMP limitations. So we have designed or we have created a prototype of an agent initiated network protocol, and we named it NMS. So just to give you a brief explanation, CNMM stands for Cloud Network Management Model. It was a paper published in 2018, which said that it's a hypothesis. They have not tested anything, so, but they have hypothesized that an agent-initiated network protocol, where usually know that SNMP is a manager-initiated one or manager-based one, where manager sends a request to the agent and agent replies with the information. Instead, here manager plays a part of listener and agent is the one who keeps communicating with the manager. That is the system we have designed. Uh, and the main objective that we are trying to prove with this new system is to show that the CNMM hypothesis model is better than the SNMP. So, just to give you a demo, uh, I will show you the virtual machines that we are running today. So, overall, there are 8 virtual machines running, uh, one two managers, one for NMS and one for the SNMP, and overall 6 agents, three for the NMS and three for SNMP. So let's look at NMS first. So in NMS, we have already run some tests before. So we'll just walk you through the what manager does. So if you look at this, this is like a feed for the manager. So if there's any issue or if there is any change in the metrics, agent initiates the information sent, and this is what the manager would be able to see. So if there is any drop, you can see there's a drop and you will see the reason why. If not, this is the main common thing you would see. There are three kinds of message types that we've set up in NMS. One is heartbeat. So every 60 seconds, agent sends like a kind of a ping saying that the agent is still online. And the second one, event, is when there is a change in the metric, or if there is a difference in the metric at a certain level, it will send a, uh message to the manager. And the third one is alert. So we have set some warning and threshold values. So whenever the metric crosses that particular value, you will get an alert message. So just to show you an example, uh, if we go to the manager, and if we look at the for alerts, you can see whenever there is an alert, you can see it pops up on the screen straight away. And this is how the normal feed would look, where it looks like a kind of a gibberish, but you should be able to filter out uh, different kinds of messages based on the requirement. The main goal here is to prove that the system we designed is better than SNMP. So just to prove that, we have created some tests. So I'm going to run some tests to look at some numbers. So as of now, I'm sending a latency test to the agent one. It has calculated it took 46 milliseconds for 57 alerts. Let's run the same thing with the agent 2, and you can see it took only 28 milliseconds for 43 alerts to reach the manager from the agent. And let's do agent 3. We can see that it took only 46 milliseconds for 45 alerts to reach the manager from the agent. This shows how quick the system we designed is. It's a very lightweight design. The reason is, since we have not loaded the whole MIB on the system, it's customizable. You can add whatever metrics you want. As of now, we have added only CPU, memory, some network related metrics, so that we don't load up the uh, prototype. And to see what bandwidth it consumed over the duration of all these alerts, we can run this. It shows all the bytes it has consumed. So from the agent side, you can see there is 440 kilobytes of network overhead during these alert period. And in the same way, if we look at the SNMP part, let's switch to SNMP. So SNMP manager. So you can see there's already a test on the screen at the moment, with an average RTT of 131 milliseconds. This is RTT, so it's a round trip of request going from the manager and getting a reply from the agent. So let's say if we are looking at latency, even if you consider half of it, the system I designed is much faster. We will run a test again for you, just for a demo purpose. So I'm running the live test. All it does is send SNMP get 10 times, so that we can calculate how long it took for the information to go from the manager to the agent and receive an information. So you can see it took 111 milliseconds for the round trip. Even if we half that, it is around 55 milliseconds, which might be closer to the first agent you have saw, but compared to the other ones, you can see that it's very less. And the overall bandwidth for these 10 pole itself is 732 uh, kilobytes. That shows how network uh, overhead or bandwidth is high in SNMP compared to the system we designed. So this proves that the system designed, or the agent driven protocol is a much better option compared to the legacy SNMP.